Yeah, do the 3 so you can have 3 decimal places, that's fine. Now what we need to do is find Z being 1.667 in our tables. So we come to our tables, here's Z, here's 1.6. Now we go along, if I use a bit of paper as a ruler.
We're not because we're not doing 1.7.
Well, we'll do it 3 decimal places. Okay? There's 1.6. There's 1.66. You happy with that? Okay. So there's 1.6 on the left. Here's 1.66. If I want 1.67, I look over here under my 7 column, and I've got to add 7 onto that. Now I don't actually add up integer 7.
Wait a second.
Instead of
if you want 1.667.
Yeah, if I want 1.6 is 0.9452. 1.66 is 0.9515. 1.667 is add 7 onto 9915, you get 9522. Okay? So if I write that down a minute, if we're using the tables, we said that a Z value of 1.6 we could read off really easily. That was 0.9452. 1.66 we needed to go across our tables, across that row until we're under the 6, and then it said 0.9515. Then when I added the extra decimal place, that's 7, what it said over on the right was I had to add on 7. So I did 9515 plus 7 is 9522, so I get 0.9522. We can do another one of those in a minute. But that would mean if we chose a random boy from year 13, the probability they were shorter than Alex is 95%. Yeah, it's 0.9522 probability.
If it was finding they were bigger, would it be 1 minus that?
Yes, it would. Yeah. If it was finding they were bigger, it would be 1 minus that. If it was finding they were exactly the same height as Alex, 0. Yeah. Billy didn't even say the answer that time. Very disappointing. Okay. 0. Yes, that's right. Okay.
Is that for the opposite? So essentially you pick it out, you just take it, but then you take it away.
Yes. If you wanted to do a greater than, these tables here are less than tables, and it's really important you know that. The clue is they shaded in to the left of the Z value. So these tables here always give you the probability of being less than, or less than or equal to, because they're the same. If you've got to do greater than, or greater than or equal to, you just do 1 minus your answer.
Tables stop at 2.9, or would they go on as just the simple stop?
They effectively stop, because if you look over here, 2.99 is already taking you to 0.9986.
Does this work if you're looking for the probability of less than something that's like way to the extreme sides of the movement, or would it work?
Well, it would just be that they would have to print these tables to more than 4 decimal places. And in real life, if something's that unlikely, it doesn't crop up very often, so they're not in here. If you did it on a calculator, then in a minute, what I want you to do is find out how you get that number out of the calculator. You could probably put in that one that we had that wasn't never going to work for Alex, 3.33, and it would probably give you 0.999999, something like that. Yeah.
Why is it if you put in just 0, it comes out exactly 0.5?
Because of the symmetry of the curve. To go back to the drawing I had here, this is a transform Z curve. It's always symmetric around the mean. We fiddled it, the Z thing, so it was a mean of 0. So the probability left of 0 is half the curve, 0.5. That's where that comes from. Right, now your challenge, because I can never remember how to do this and calculators change each year, I don't know whether Greg will help us out with this, but if you find somewhere on your calculator something to do with a normal probability, possibly a cumulative normal, you will need to put into your calculator a mu value, a sigma value, an x value, and if you can get an answer out of 0.9522, you have found all the right buttons to press. Okay, I'm going to pause the video at that point. In a minute, when someone's done it. Oh, Ben, can you do it now? Can you show us on here then? Okay. If you show it on here, we'll record this as well, this bit.
Or is it on here?
Okay. Zoom in with the T if you want to.
I think
don't
you're
you?
right.
Okay. So, can you all listen?
Right, so just go into stats, and then distribution with F5 on the green ones. I'm not sure if it's the same on the blue ones. Then normal, and then cumulative, NCD.
MPD, NCD.
NCD is the cumulative one. NPD is just sort of that point. Then you put in the lower, which is 0 in this case. Upper is 195 because it's the value we want.
Can we? I don't know if we can zoom in a bit. See
Yeah,
actually your
it's not
screen a
quite there,
bit
is
better.
it?
Hang on.
It's a bit dark. There we go.
This standard deviation is 6.
Yeah, and you put your
Mine doesn't say that. Mine gives me like a. I've just got the. Gives me a sigma and a mu.
oh, what? Sigma and a...
I've got L-this.
Yours probably does differently. Is yours a blue one?
Mine's a sigma and a mu.
Yeah, yours is a better calculator.
Would make more sense
And then
to me, I think, actually. But basically, if you can get that on your calculator, you probably found the right thing.
About 29.
so yeah, that's
Do you want to take yours up
It's the
here?
same, it's just a bit numerous.
yeah. Your one's a bit newer calculator. So
Can you do yours as well? Does anybody know what calculator Chelsea's got? Because she'll be watching this and trying to do it. Okay, so you can do that on there, okay? Okay, so just talk through what you're doing again on here.
So, I mean,
Like from scratch. So you know exactly where you've gone from the opening screen.
I'll go back to the home menu. There, so you go to stat, distribution, normal, and then cumulative. And then the lower is 0, because you can't be smaller than 0. The upper is the height of Alex. So it's finding the probability of anything between the upper and the lower. And then that's standard deviation, which was 6. And the average, the mean we said was 185. And execute. Should give you that.
I've
Okay.
just got a few extra features in.
Thank you. I'm just going to stop the recording at that point.